13.8 billion years ago, the universe appeared out of apparent nothingness. Aristotle's view of nothingness stated that nature abhors a vacuum and would do anything to stop it. You can view this in a simple straw-sucking experiment, where the straw collapses if you try to suck the air out of it. In 1643, the Italian scientist Evangelista Torricelli was able to create an empty space for long enough to study it. He filled a glass tube with mercury and released it after inverting it. He was able to create an airless space, and he was also able to demonstrate that air has a weight. The French scientist Blaise Pascal was able to further refine Torricelli's ideas. He found that the pressure of air falls the higher you go. Torricelli and Pascal stated that Earth is cocooned in an atmosphere that thins out into space. Their work showed that nature does not abhor a vacuum, but in fact, vacuum is nature's default state. Gradually, scientists were able to see that sound waves couldn't travel through vacuum, but light could. This suggested that a vacuum is not exactly empty. They wondered what carried light waves through a vacuum chamber and why they couldn't get rid of it. The belief at the time was that all space was filled with luminiferous ether, which is totally intangible to measure. In the 1800s, the American scientist Albert Michelson was working on precise measurements of the speed of light. In 1883, Edward Morley joined Michelson in Cleveland, Ohio, and together they tried to make instruments to sense the ether. In 1887, they set up an experiment in a special mercury bath. They started with a light source followed by a beam splitter and two mirrors to reflect the light back onto a detector, which focused the light on a paper. If light traveled at the same speed in every direction, a white spot would appear on the paper as the light beams would reach there simultaneously. If, however, the Earth is moving in a stationary ether, the experiment would behave in a different way. The recombining spot should be dark, because the speed of light would be different in different paths. Their experiment always showed a bright spot on the paper. Michelson and Morley were so convinced that the ether existed that they thought their experiment failed. It is now that we know, due to the work of Einstein, that light needs no ether to move. Light is a fluctuating wave that literally moves through empty space. By that time, vacuums were making big business. Light bulbs, televisions, X-rays, and even the discovery of the atom used vacuum technology. However, in the quantum world, it seems to be impossible to ever have truly nothing. The German scientist Werner K. Heisenberg deciphered that quantum physics is a world of uncertainty. A simple way to look at it would be to look at an image and a video. In an image, we do not know the movement of an object, but in a video, we never know its precise position. In the quantum world, at one point in time, both of these quantities cannot be exactly determined, and at the subatomic scale, the uncertainty is an inescapable feature of reality. This is Heisenberg's uncertainty principle. Another question is whether there is energy inside of empty space. The answer is yes. If you're able to slow down time, then what is the energy inside the space? It turns out that in smaller intervals of time, there is so much uncertainty about the energy inside that could create particles out of nowhere. The vacuum is alive. This was all elaborated further by an extremely gifted British physicist named Paul Dirac. He unraveled the deepest mysteries of the vacuum and what happens in empty space. Dirac was able to unite Einstein's theory of special relativity and the rules of the quantum world. He derived a mathematical description of an electron. His calculations showed that it needed 4 equations to view the behavior of the electron. The first 2 were already widely used, but the other 2 were not known until then. This predicted a new particle, same as the electron, but also very different. It was an anti-electron. This led to the concept of the anti-atom, or as a matter of fact, antimatter. Dirac's equation showed that matter could be created out of a vacuum. Within nothingness, there is a dynamic dance of particles and antiparticles. But when matter and antimatter meet, they annihilate each other and disappear. Nothingness, therefore, has virtual particles appearing but then suddenly disappearing. Dirac gave a completely new picture of the vacuum. It goes from nothing to be sprouting virtual particles. This is known as quantum field theory. In 1955, the American physicist Willis Lamb showed that electrons have precise energy. He was using microwaves and lasers to probe electrons in a vacuum tube. In it, if there are virtual particles, electrons will be perturbed by fluctuations, and you will see a peak on the detector. If the vacuum was truly empty, there would be no peak and instead a flat line. Lamb did observe the wobble in the electrons passing through the vacuum tube, and said that even if you remove everything, you can't remove the mysterious energy inside space. Now we're getting closer to understanding the hypothesis that the universe sprang from a vacuum and expanded very rapidly. Quantum reality has shaped the structure of the universe that we see today. Our universe is actually the quantum world inflated many, many times. Nothing has really shaped everything, and we actually have a way to see this now. The WMAP space mission was able to generate a picture of the first light released after the Big Bang. This is like an embryonic picture of the universe. The picture showed that the matter of the universe did not spread evenly. The quantum fluctuations in the vacuum were actually the seeds of the universe. There was one final revelation. Our universe sprang out of a vacuum, creating not only matter, but the strange substance predicted by Dirac. However, the universe we see today is made of matter. All the antimatter seems to have vanished. The latest theory is that for every billion particles of matter and antimatter that got annihilated, one matter particle got left behind, and that is what we see today. Matter and antimatter annihilation gave rise to the radiation that we see as microwaves today. So, we are simply the debris of a huge annihilation of matter and antimatter at the beginning of time, the leftovers of an unimaginable explosion. There is therefore a profound connection between the nothingness from which we originated and the infiniteness in which we are engulfed.